Today we're diving into one of the most fundamental data structure, the stack. So specifically, we're going to implement a stack using linked list and Java. So this is a common and efficient way to handle stack operations. At the end of this, you'll know how exactly. So what is a stack? So a stack is a LIFO structure. So the stands for LIFO is last in, first out. So the easiest way to remember this is to think of a stack of plates. The last plate you put on the top of the stack is the very first one you take off. So we build this using a linked list. So we make all our operations happen at the head of the list. So which we'll call the root or top. So we'll be creating 4 main methods. So push to add and pop to remove, pick to look, and is empty to check. This is the blueprint class structure. So let's look at the code. Our structure has two main parts. So first, on the right, so we have our stack node class. So this is an inner class that acts as the building block for our linked list. So each node hold its own data, so an integer and a next pointer, so which points to the next node down in the stack. So second on the left is our main stack as linked list class. So it has one crucial variable, StackNode root. So this root is the only thing we need to keep track of. So it's the top of our stack, the node that was most recently added. So first, let's look at our helper method. So it's empty. So this one is simple. So since root is the top of the stack, so if root is null, it means there are no elements. So we return true. Otherwise, we return. So now is the main operation push. So this is how we add a new plate to the top. So first, we create a new node. So with the new data, so we check if the stack is empty. If it is, we just set our root to be this new node and we're done. So but if the stack is not empty, we have to link it. So we save a reference to the current root in a temp variable. So we set our new node as the new root. So finally, we link the new root to the old stack by setting new node.next equals temp. So the new node now points to the right. So now let's get the data of the stack. So the pop operation, this removes and returns the top element. So first, we check if the stack is empty. If it is, we print an error and return a nothing value. So this from stack is empty. So if it is not empty, we save the data from the root node into a variable called pop. So then the magic happens with one line. So root equals root.next. So we simply move the root pointer down to the next element in the list. So the old root is now gone. So finally, we return the pop value we saved. So the pick operation is much simpler. So it's like a pop without the removal. So it's like a pop, but there's no removal. So we're just checking the top of plate without taking it. So we check if the stack is empty, and if it's not, we simply return root.data. So the stack itself is not changed. So let's run our main method to see this is all in action. So first, we create a new stack as linked list as our main class. So we push 10. The console prints 10 push. We push 20. So the console print 20. So 20 is now on top of 10. So we push 30. So the console prints 30 push. So 30 is now at the very top. So our stack now is 30, 20, and 10. So next, we call the method sll.pop. So because of LIFO, the last element we push 30 is the first one to be pop out. So the console prints 30 pop from the stack. So finally, we call SLL.peak method. So after 30 was popped, the new top of stack is 20. So peak confirms this by printing top elements is 20. So without removing it. So this is the overall console output of the code we demonstrate. So, and that's it, how successfully implement a stack using linked list in Java. So as you can see, using a linked list for this is very efficient. So our push, pop, and peak operations all run in a constant time of 001 time. So this is because we only ever have to work with the head of the list. So thank you for watching, and if you found this helpful, please hit the like button, so and also subscribe. So please let me know, and I'll see you in the next one. So if you have questions, comment.